couple things. So I'm gonna, why don't I just go right to sharing my screen? Actually, I just want to make sure that's not somebody trying to. Oh, that's just me telling myself I'm live now. It's not supposed to like tweet at me when I'm on camera, but anyway, it did. Okay, so I'm gonna go right to sharing my screen to show you a couple things. So what would help if so we're on week 4. And it does not have all my stuff. It's been doing this lately where I have to push publish 100 times before the stuff shows up. But there are a bunch of things. Hopefully they're there now. Come on. Nope. There they are. Okay, so there are a bunch of things, links that will be useful while we're talking today. So you might want to just open that up week 4 on the website because you are going to want to take a look at them. So we are, hopefully, I forget what the date is on problem set 1. When is that due?
Monday the 19th, I believe, for the second part. And the first part was yesterday.
Yesterday, okay. So great. I thought you had a little more time. So, so if you're having any trouble with that, I have noticed that a bunch of people have posted on the discussion forum. There's one student I got to chase down. I saw him yesterday, but we'll have to get that. So it looks like some good, bad maps, which is great. And so I'll be responding to some of those as well. I'll take a look at them. And then you should be working on your georeferencing. And I know a couple people have already handed those in. So you have some time before they're due. Feel free to contact me about problem set 1. The other thing that I wanted to mention, and thank you, Felicia, for bringing this to my attention, is that I forgot to post the data for the tutorial for this week. So it's there now. It's a just a zip file called editing, and it's just the tutorial data for this week's tutorial. It's going to go through some stuff that if we can today, we'll start. I have my doubts because we were supposed to a couple weeks ago cover deed descriptions
Does that basically link to the tutorial for the data for the editing tutorial from Esri or something different?
Yep, that's right. Yeah, and you were the one who told me that that was going on. Yeah. That I didn't.
So was it for the Esri tutorial, or are we doing? Is it not an Esri tutorial?
It's not one that you sign in for. It's one, yeah. So it's an Esri tutorial, but it's one that is just free, and it's posted basically in the help stuff. So it looks a little different. So you just follow it. There are looks like 5 exercises. It goes through. We're not going to look at. I don't know. We'll see. If we have time, I'll look at spatial adjustment and data that we use. But it's going to go through some stuff that we're going to be doing in class over the next 2 to 3 weeks, and that will be part of your next 2 problem sets. And so it's a pretty important tutorial. So and the way these tutorials work is if you can download all the data for all the tutorials, but there's a whole bunch of tutorials. Like if you go to any part of ArcMap, there's often, I don't even know how to find them. But anyway, there's tutorials, a whole bunch of tutorials that are in the help website, and the data for them is downloadable. So if you go back to the website where you pretend like you're activating your ArcGIS code, they'll give you an opportunity to download the tutorial data. It's pretty big. It's like 1.6 gigabytes. So I did not want to make you download the whole thing, but it's there if you want it. So I downloaded the whole thing, extracted just the editing piece, and then posted the editing data for you where you can find it. Does that make sense? All right, so that's posted, and I apologize that I missed that. I meant to go back and do it. And hopefully you're on the week 4 page of the website. And what we need to do today, though, I'm going to babble at you some today. This is really important stuff. It's good if you ask questions. Some of you who are already working for municipalities, feel free to toss questions out there. If they're really good ones, I'll share them with the whole class after you watch this video, since we only have Jen and Felicia here. There might be some...
Good question, not quite related to municipality. You said it was the number 2 use for GIS. What's the number 1?
Number 2 use for GIS. What did I say was the number 2 use?
Municipality was the number 2 use of GIS.
Probably environmental applications are number 1.
That makes sense. I was just curious, what's number 1 if that's number 2? Thanks.
Yeah. You know, it may be that land records and municipal uses have grown enough that they're now moved into number 1, you know, in terms of how many people use it. But in terms of actual just straight up jobs, there are many environmental jobs that are just GIS, and probably fewer people. So like in Maine, people who do GIS for municipal applications, there's a huge demand for it, like way big. I have several towns right now that are waiting for me to help them with their tax maps because they can't find people to do that for them. So it's a really good way to make money as a consultant. But few of those towns hire straight up GIS people because they're, you know, small municipalities. So, okay, so we talked about, and you've been reading about land records in class, in your book, right? In the Von Meyer book, Nancy Von Meyer, who's awesome and nice and everything. She is, so that book talks a lot of, I'm going to repeat some of the things that she talks about in that book, but we're going to do 2 things with it. One is I'm going to highlight the things that are relevant to you and to what we're doing in this class. The other thing that I'm going to do is we're going to actually apply it. We're going to do this today. So, we're going to, I don't know why my thing is just tweeting at me constantly. What the heck? I should have left my phone somewhere else. Okay, anyway. So what we're going to do now, what we're going to do today is I'm going to talk first about legal descriptions and how they work and why we use them. And then we're going to start digitizing tax maps. So you guys have been georeferencing tax maps. Now you got to figure out what you do when you georeference them. And it's a pretty important, really important job. So let me babble at you for a while. Stop me if you have questions. And then we'll launch into it. So a legal description is a really, really crucial thing. It's not something that a GIS technician makes. We don't create legal definitions or descriptions of property. We have to use the legal descriptions and make maps that show what those legal descriptions describe, right? And it's called a legal description because it is registered with a county in Maine. It's a county agency called the Registry of Deeds by a lawyer, and it is typically created. In most states, it's created by a licensed surveyor. In Maine, it's not required that you're licensed. They do license surveyors, but they don't require that surveys are done by licensed surveyors. Incidentally, if you ever hire a surveyor, hire a licensed surveyor. You will, as we work with some of these land records, these legal descriptions of land, you'll see why you want a trained, certified licensed surveyor. And, you know, it's surprising how many people they're shocked and amazed at how much it costs to get a survey done. But what you get out of it is often crap if you don't hire hire a licensed surveyor. Okay, so the American Congress on Surveying and Mapping, ASCM, which is kind of the professional organization of licensed surveyors, defines a legal description as a description recognized by law, which definitely locates the property. And where the reason I say, why do you think I say you can take the word definitely with a grain of salt? What do I mean here?
Margin of error?
Yeah. There's some like actual measurement error, but
it's going to be an error no matter how accurately they try to measure it.
Yeah, so some people don't know how to measure accurately, so that is a problem, and I have run into that. The other thing that I run into probably more often is that the description doesn't make sense, right? So, for instance, if you have a piece of property and it has a bunch of sides, you would think that if you started at one point and then drew a polygon that of the description so that you're drawing what's being described, that you would end back at the beginning, right? It would fully enclose, it would close the polygon. Some descriptions don't do that. It's actually hilarious, sort of. It's really upsetting to the landowner and to the town when you try to digitize a legal description and it doesn't close. It's a total pain in the neck. So it's super common. It's also super common for people to reference things that are in the landscape but ephemeral. So older surveys and untrained surveys nowadays will do stuff like, say, starting in the center of the stream. Streams move around. Like if you go back 10 years from now to the same location, the stream will not be in the same place. The other thing
that's not a good thing to use for making a measurement, or georeferencing or anything.
Yeah, no, it's too ephemeral. It's ridiculous. And in fact, there's a boundary between two states. I think it's South Carolina and Georgia that has been in dispute for years because it was originally surveyed along the bed of a river, which is totally in a different place. And so since that was the legal description of the boundary of a state, that's what they used throughout all of history. And it meant that that as the river moved, the boundary of the state was moving, and they went back to court and dithered and so forth. I don't know if it's ever been resolved, but there were water rights involved. So it was a real problem for both of them as they were, trying to provide. So Georgia was trying to provide water to Atlanta, which is one of the biggest cities in the nation. Anyway, so it's a huge problem. It's something, if you work with land records at all, you will run into. Some of the, old deeds that were registered in like the 1840s or something are just gibberish. They just don't make any sense. They reference a fence that, hasn't been there for 100 years, or an apple tree that hasn't been there for 100 years. And so very often what a landowner will need to do, or a town, depending on the situation, is to hire a surveyor and to go back and actually decide, based on the best guess that they can make, essentially, where the boundary should be. So it's a common problem. Okay, so there are essentially two types of legal descriptions. So you'll find, so there are what are known as conveyance instruments. So those are descriptions that are in deeds and sometimes in contracts that are used to describe in words the location of the parcel.
Hang on, a deed is called an instrument? That usually implies like a tool or something.
So this is a sort of an instrument. It's a legal instrument. So it's a document that contains a description of the property.
And so a document can be like a tool. That's kind of funny.
Yes, yeah. And so, and it's a particular type that's recognized by the state legally and recognized by the county, and the county registrar of deeds. There's usually a person, and that person usually has staff. And so they are legally allowed to register deeds and record them and keep track of them. And in a minute, I'll show you the Washington County Registry of Deeds. And so they record the conveyance, and conveyance means transfer of property. So what is conveyance? I thought maybe you were focusing on what you were eating and not on what I was saying.
Convey means to explain.
Nope. Well, in this case, it's a good idea. It means to transfer property. So typically, almost always, a conveyance is a purchase, but it might be just giving away, right? So to convey, a conveyance is a transfer of property. And there's Shelley, yay. So hi, Shelley. So a conveyance instrument is a document that's used to convey, to give land to another person. There are various types of those. I'm not going to get into them, but we will look at some deeds. I think I have a couple types of deeds for you to look at today. And so we'll take a look at some of them. But the thing about these is that deeds are typically written by lawyers, and well, typically they're written by surveyors, and lawyers approve them. They make sure that they have all the right legal arguments, and then the lawyers file it with the Registry of Deeds. Also, very often a survey that is a plain view, so a view from above of which is essentially a map, right? A view from above of a property or subdivision. That is another type of legal description. Now, we're going to get to, let's see, let's go here. So just to talk a little bit about what you see on a plat or a plat map, that can be a legal description. Notice this is in black and white. It is only in black and white. That's a legal requirement in the state of Maine anyway, and it's consistent across the country. I've never heard it be different. The reason is it's easy to reproduce without any special equipment. It's a little bit of an archaic requirement, but it is the way we do it now. So in order to be a legal document, a legal description, it needs to be in black and white if it's going to be a survey. And it has some really important information on it, which we'll take a look at a little more closely in a minute. There are a couple of terms, and your textbook talks about them. I took this diagram from your textbook. One is called bounds. So remember, Nancy refers in the book to calls. Those are statements about that are describing the land, and so that refers to the calls refer to neighboring parcels or features. So something at the corner of a parcel, like these trees, or along the edge of the parcel, like the road or the river. Those are referring to those descriptions, and so bounds refers to those things. So these are examples of bounds. Let me zoom in here if I can. And this again is from your textbook. So this is a call. Lands bounded to the north by this is a boundary call. Lands bounded to the north by Hogan's Woods, to the west by Happy Road, and to the east, blah, 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 right? So that is, and often, usually if you refer to land owned by someone else, you refer either to the name or ideally to the book and page number where that deed is registered. in the Registry of Deeds, or both. So a good surveyor will include both. And so these are boundary descriptions, or bound descriptions, beginning at the center of Old Time River where it crosses Dairy Road, thence southerly, and so direction. These are very coarse bounds because it just says southerly. And sometimes it'll say in a general southerly direction rather than really specific, but we'll learn that you can have very specific bounds, directions for bounds, and we'll talk about how those are written. So that's what bounds are. You've probably heard the term meets and bounds. And so meets are measurements. So a meets are a series of measurements, usually directions and distances from points of beginning. So a survey or a deed will describe, a point of beginning, and then say 100 feet south by west, south is 0 by west, and I'll show you how these things work. Thence, north by west 70, and so on, until you come back to the point of beginning. And remember what I said at the beginning, one good piece of evidence that you've got a crappy survey is you go through all the meets and bounds as described, and you do not come back to the point of beginning. That happens a lot in old surveys, especially when they were done by, somebody who doesn't know stuff. So this is how it looks in an actual deed. So this is how it's described in words in a deed. And so you can see beginning at an elm tree. So here's the elm tree, and it's an unfortunate choice of landmark. So more typically a new surveyor will put an iron bar or pipe in the ground and measure from that location, or something else that's more tangible. And so trees, generally, you don't want to see that in a deed, but you do. So beginning there, then south in this direction.
Well, I guess if the pipe's still there, and you got the angles, but no, then you have to know where the other side started from too.
That's right. Yeah. So this situation isn't too bad. If the pipe is still there, then you could measure this ostensibly. Although if you don't have the direction, no, you couldn't. It would be a pain, very much a pain. Anyway, so these kinds of descriptions are known as meets and bounds, and so that's what they're referring to there. So let's, I'll come back to some of these other pieces. I'll continue on. I'm going to continue on. So not in Maine, but in other parts of the country, it's important for me to mention this, and she does talk about it in the textbook, is the public land survey system. We actually have in northern and eastern Maine, so in this area, we have the remnants of a similar system, but we don't use it anymore. It's what led to what we call the unorganized township numbers. And a lot of the towns that we have that are organized currently in Maine began as these land parcel system quadrangles, so squares essentially plugged into the land. But a lot of the Midwest still uses this public land survey system, PLSS, and they're numbered according to a sort of grid pattern. She describes it in greater detail in the book. It's not used in Maine, so I don't really go into it in this class. But there are different types of parcels. They were called sections, and they were 160-acre sections. They were most often subdivided into quarter sections. So if you've ever heard of somebody refer to a quarter section lot, that's what they mean. And those quarter sections, not surprisingly, are 40 acres each. So sometimes a half section, etc., quarter. So there are lots of different ways they were mapped out, and they were really easy to map, especially in flatland like out in the Midwest. So that's a really important pattern that you see that you'd have to get used to. All right. I think Felicia might be falling asleep.
Sorry about that. I have sinus headaches, and I'll just close my eyes sometimes to relax them. My eyes aren't that bad. I shouldn't blank out on you. Sorry. They're not that bad today.
It usually doesn't happen when I'm on an online call, but sometimes. So another kind of description that you'll see, and you will see this both in words and on a plat map, is what's known as a strip description, where you have the points of a road, but it's only measured by its center. So you have the center line drawn on the road, and then you describe it by how wide it is, right? So this is a 66-foot road, and it's described by its center line. You might have the latitude and longitude of each of the points on the line, and that's how you would describe it. You can also have, and this is a little weird, you can also have a curve or arc description, and those are common, especially nowadays, because there's software that can make those really easily, and a lot of, so CAD and ArcGIS both have the capability of creating polygons and things and lines on a curve of particular description. So let me show you how that works. I have an example, so we'll come back to this. So a curved line is usually described as the change in direction over the line's length. That's the delta, the radius of the curve. So where the center of the circle that would be described if it went all the way around, where that center of the circle would be, and the length of the arc, so how long this arc is. And so those are important pieces. And an arc can be tangent, which means that it begins going in the same direction as a line that it's attached to, like this. Or not. It can be turn a corner right at that point, right? And so it'll be described based on where it begins in terms of where it points as it turns off. Let's see. All right, and so a subdivisions are really important. And they're typically, most towns actually require a subdivision plan or plat to be submitted to the town for approval. And there's an official definition, here it is. Maine has an official definition, which is the division of a tract or parcel of land into 3 or more lots within any 5-year period that begins on or after September 23rd, 1971, which is when this statute, I think, went into effect. So if you chop your lot once and then chop it again, all within 5 years, then you're making a subdivision, and that triggers certain regulations. A subdivision plat looks like this, a survey. We'll take a look at one. And yeah, I already said this. Okay, so let's take a look now at one of these kinds of surveys. So again, go to week 4. I'll post it in the chat. Where is it? There it is. We'll post that in the chat. And if you go to that page, we'll start with, click here to download the quitclaim deed example. So this is a fictitious example, it's not real. But I'm gonna show you how this works. And in fact, maybe I'll do it here. Put it up here after our meets and bounds discussion. So I'm going to actually draw it. I'm going to draw the parcel described. It's something that I typically do, I often do when I have a parcel description that that I need to digitize. So I'll begin there by just drawing it. Often I'll do it right on a piece of paper with a pencil. It's super helpful to do. Do you find it? The quitclaim deed. So it's this link right here. So let me zoom out a little bit. Okay, so I'm going to draw it for you right in our little PowerPoint here. So a certain lot, notice too that they almost never actually, which is a little frustrating for me, they often don't include the map and lot number of the parcel for the town. Very often, towns that have their stuff together will, when they record a deed, they'll get the deed and then they'll actually stamp it with its lot number and file it with the information. But a lot of towns don't and don't have the information about which lot is associated with which deed. And so that's a problem I've run into a lot, a surprising amount. So, so you won't find that there. One thing you sometimes have is if the, well, so usually the person who's conveying the property, selling the property, is not, it no longer resides at that property, so the address is not going to be the same as the parcel itself. Okay, so here we are at meets and bounds, and it's describing, so beginning at an iron rod found 28 feet more or less from the low water line of Indian Lake at the northeasterly corner of land now or formerly owned by these people. Said premises is described of blah, blah, blah. So they are calling, that's a call to a previously registered deed in the Registry of Deeds. And so there's an iron rod, and it's a few feet more or less from the low water line of Indian Lake at the northeasterly corner of some property. So, oh, and then, let's see, I'll put my little iron rod here. I don't yet really know where it is, so I think that's probably a good spot for it, but we'll see. So there's my iron rod. And here's a thence, right? Thence. It goes this way. How do you know what that is? What is that? Isn't that weird?
Coordinates south and west.
South and west, yep. It sort of looks like coordinates, but it's not.
Yeah, you're right. 75 degrees south and looks like minutes west.
Yes, yep, that's what it is. 75 degrees, 1 minute west. And sometimes it's degrees, minutes, and seconds. It's often degrees, minutes, and seconds. And so these are what's known as quadrant bearings. So we need to go back and learn about these guys, quadrant bearings. This is how those things work. So this description says south 75 degrees, 75 degrees, 1 minute west. And so this is a way of describing directions based on the compass in quadrants like this. So for example, let me find oh, I don't have an example. So if it said north 52 degrees east, this is how it would work, right? So it would be starting north and going 52 degrees to the east. This is the direction. And the north and west would go in this direction. This is south and east. And then, of course, south and west would be in this quadrant. So from the point of beginning, right? So here's the point of beginning right here. From that point, thence, we're supposed to go in this direction 208.2 feet, more or less, to an iron rod. And so we have to draw a line like that. One important consideration, though, and this is really crucial, is that this is a compass direction, and the surveyor, when the surveyor went, it's common practice to use a magnetic compass. Why does that matter? Why would it matter that they used a magnetic compass?
What kind of compasses are there?
There are two. Magnetic and true north are in different positions. Good, good, Shelley. Yes, magnetic north and true north are in different positions. So we need to find out how magnetic north and true north differed when the surveyor did the survey. And so one thing we need to do, see, they're oriented. Sometimes they say this, sometimes they don't. But oriented to magnetic north on August 10th, 2011. Why would they give us a date? Why does it matter what's the date?
Because the magnetic pole is constantly changing.
Good, exactly. The magnetic pole is precessing, that's what it's called. It's wiggling around. And so we need to know what the difference was between true and magnetic north. It's called declination. And there's a calculator, declination calculator. Geomagnetic calculation, declination. So let me zoom out a little bit here so you can see what we're looking at. And I'll post this on the chat so you can see it. I don't have my chat anymore. There you are. Okay, I'm gonna paste that in there so you can see that. So magnetic declination, estimated value. It doesn't really, I haven't noticed a difference between the two models, but we need the latitude and longitude. And for that, I'll just go to, this is Whiting, Maine. Just go to that on Google Maps. It's not going to be hugely different, so it doesn't really matter. So I'll right click and choose what's here. And I get latitude and longitude here. I'll copy that. I can paste it. So the latitude is this. Longitude, it actually, in this case, doesn't want the negative sign. And instead, it's going to have us do west. So that's the latitude and longitude. And the date from my quitclaim deed is, where'd it go? Okay, I had it. I don't know what I've done now. What did I do? There's my deed example. I'll put that over here. So, and it's August 10th, 2011. That was my son's 5th birthday. That's pretty cute. I wonder if I did that on purpose back in the day. Oh, I see what the problem is. Okay, there it is. This can go away. So it was 2011. Oh, it won't go back that far. What is wrong? That's no good. Oh, I think, oh, here it is. It's because of the new, it's IGRF. You have to choose the other one, other kind of calculation, and you can get the results in many different ways. You can also incidentally use the zip code thing, or there's all different ways to find the latitude and longitude. But so you know, do your best. Sometimes if I have a lat and long in the deed or on the survey, I'll use that. Just choose that randomly and I'll click calculate. When I do that, it says, okay, there was the declination. So the declination was 17.35 degrees west. So that means that magnetic north was to the west of true north by 17.35 degrees. Okay. I commonly write that down when I'm in the mode of sketching a piece of property. Here's my property I'm sketching. So I'm going to paste that in here so I have it. I want it to be big. Oh, right, this way. So that's my declination. And I'm going to park that up here so I have it when I need it. And so now this first meet in my deed, beginning at an iron rod, blah, 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 right, is south 75 degrees, 1 minute to the west and west. Blah, blah, blah. Oh my gosh, I gotta get more sleep. So south 75 degrees, 1 minute west. I'm going to copy that if it'll allow me. I'll paste that in here. It does allow me. That's good. So if we've got this 75 degrees, 1 minute west, and we have a declination of 17.35 degrees, that gives us a little math problem we have to do. And we're going to want to think through it. Incidentally, let me remember it's 208.2 feet. They're almost always in feet, incidentally. Okay, so I have to figure out what real direction that is in if I'm working with non-magnetic compass direction. So let's think about that for a minute. So first of all, let me get a quadrant. And so if I have a quadrant like this, right, and I have a point south and then west about 75 degrees. So it's about there, right? Out here. So south and then 75 degrees, 1 minute west. Right? So that's what we're looking at in this deed here that we're looking at. But that's magnetic. So, okay, think through this. If we've got a declination, this is our declination, how do we need to change this? Oh. There we go. Paste. There we go. So we've got the declination. How do we need to change our declination? Just gonna move these over. Oops. Move these over here. So it's too far. Yes, good. We need to go 17 degrees, 1 minute to the east. exactly. So that means we need to go this way, right? That way to the east. So, and there are a couple things we can do, ways we can do it. We can convert this to decimals, or we can convert this to minutes. You want me to do the harder things so that you can see how to do it? Trying to decide what I think you should do. Let's do it in quadrant bearings. I guess I can show you both ways. Shelley likes easy. Okay, easy's good. Well, let's do it the easy way first, and that is to convert this to decimal degrees. So that would be 75. Why don't I just do this? So that's 75 degrees plus 1/60th of a degree, right? And so if I get my calculator and I take 1 and I divide it by 60, it's 0.0167 repeating. So it's 0. I'm sorry. So the result is 75.0167 repeating. So that is the angle now. Here, it's the same thing from the south, right? I wonder if I can. I can. Okay. So that's what that is. This is 75.0167. Incidentally, you might say, why didn't you just do this before and just show us? And it's because you would never understand. And Felicia wants to do both ways, and we can do both ways. Okay, so does everybody understand how I got this? Does that make sense? Yes? Okay, so now it's 75 degrees, 75.0167 degrees this way. We need to go that way, 17.35 degrees. So to do that, we're going to increase how far we go from south, right? It's going to run us into a little problem, but that's okay. So 17 is going to be plus 17.35. So let's see, first we need to add the 75 here. Equal, so that's the answer, that's how far that is. And I'm going to add 17.35 equals 92.36 repeating equals 92.366667. Okay, so this runs us into a problem. Any ideas what it is? Where is true north? So this is MN for magnetic north. Where's true north on my, yes, we're going northwest now, not southwest. So I need to, we've gone past the 90-degree mark, right? So now we're here, right? And the angle that we're, oops, the angle that, geez, why? There, I'm just going to use my arrows. So the angle that we discovered is this one, right? Is that one. But that's not how we measure quadrant bearings. We're now in the northwest quadrant, right? So we have to measure it like this. And if you're wondering why anyone would want to do it this way, I can't tell you. I don't know why quadrant bearings got their start, but it just is how they do it. There's probably a reason, and if you ever hear about it, let me know. I'd love to. So this little tiny angle here is 2.367 degrees, right? That little bitty slice. So that means that this angle is what? If this little slice is 2.367 degrees, what is this little slice? This big slice? It's going to be less than 90 degrees. So it's going to be, right? So the whole thing, the whole quarter would be 90 degrees. And Shelly's got it, and Felicia's got it. It's very close. So it's although Shelly, you got a couple numbers. Couple numbers.
Yeah, I knew it'd be 88 point something, I think.
Yes, it would. So let's we'll calculate it. So it would be 90 minus that little sliver, 2.36667 repeating. And so so it would be this, and I'll turn that into a negative, and I'll add 90, and it's 87.63 repeating. So 87.63 repeating. Now, you'll be relieved to know that you don't need to do this when you do the digitizing from a deed, fortunately. ArcMap has, and I will show you how to do this. Probably won't get to it tonight just because we're a little behind on our stuff. But ArcMap has a little thing where you can tell it what the declination is, and it will automatically put in the correction. It's really important that you remember this concept so you can think through and make sure that you put the correction in the right direction. Because if you put the correction in the wrong direction, all of your directions will be 17 degrees off in the wrong way. That's a real bummer. And I've had it happen to me. And it, you're like, wait a minute, that parcel is not where it's supposed to be. And then all of a sudden you realize, oh, I told it that the declination was in the wrong place. So, so these quadrant bearings, it's important to understand the concept and to understand generally what the directions are, and to be able to use them in a functional way. So let's go back. So we've got this direction. I'm gonna continue on as though I'm using a compass, because that is how I will end out inputting them. I'll show you. Okay, so now I have and I'm just gonna, generally put a line here. So it's 75 degrees roughly. I'm just making this up. And it's 208 feet, right? 75 degrees into this quadrant. So it's actually about 15 degrees off of a right angle. Okay, so there's my first boundary. And let's go back to our deed and see what we're supposed to find there. To an iron rod, so there's another iron rod. And good. So there's another iron rod. I find it useful actually to say rod, so that I know what that is. So there's an iron rod and an iron rod. Next, so from there, we turn north and west 16, roughly 16 degrees for 247 feet, more or less. Grab that little piece there so I can paste it right into my drawing. So there's my next set of meets. And so that's going to be north. So it's a kind of a funny one, isn't it? It'll be north, 16 degrees, 15 minutes west. So it's north and west. Oops. There. North and east. There's north and west. So it's going to be north and west by about 16 degrees. So it's going to go upward. I don't remember doing this, so I hope it's actually closes. So it's going to go north and west, just a little ways off of vertical. And it's going to go pretty far, farther than that. So I'm going to need some more room in my drawing. This is one reason why it's easier to do the drawing electronically sometimes than it is to do it just in pencil. So that's going to be like so. Is this helping you guys to watch me do it, to understand what the hell all these things are talking about? Little. It'll help even more when you do it. Another iron rod. So let me grab the rod and put that there. So there's that. And then thence turning and running south 89.47 for a distance of 319 feet. So put that in here, change that size so you can see it. Drag that over here. Oops. So south and west. Oops. I need more room. Again. There we go. Okay, so south and west, 89. That's almost 90 degrees south and west. So south and west, almost all the way over here. I don't remember doing this. Hopefully it actually works. South and west, 319 feet. Oh, I'm going to need a ton more room over there too, aren't I? Although it would be a good object lesson for you guys to see a, a survey that isn't very good. So that's going to be really long compared to those others. Thence running north by and along the easterly side of Barney Field Road. so-called, for a distance of 366 feet. Okay, so now there's a road in my area here, and it's running along here. And my property goes along the road 366 feet. And it's probably a good idea to put the road in as a symbol. There we go. So there's Barney Road, and it's 366 feet. And did it say north? Yes. So north along Barney Road, 366 feet. So now, I think I need to move everything a little ways down here. Thence, turning and running south 74 east for a distance of 563 feet to a rod. Okay, so what is it? South 74 east, so just a little south of north. I mean, a little south of east. So about like that, but a long way, like here. And there's a rod there. What did I say? All right. Oops. Copy that and paste. And put that in there. Oops. There we go. And there's a rod, so I need a rod symbol here. Stick that there. And thence continuing for a distance of 45 feet more or less in this direction. Oh, so continuing, right, in that direction for 45 feet more or less to the water line. So let's move the rod over a little bit this way. You can also do this on graph paper. That can be helpful. So then it's going to continue on a little further in the same direction this way till it gets to the water, right? Then turning and running along the shore for a distance of 385 feet, more or less. And then, so that's going to look like this. Let's see, I think I'm going to do polygon. So this is the shore of the lake, right? And I guess I'm not doing a polygon. So that's the shore of the lake. I'm going to make that a little thicker, and I'll make it, I don't know, blue. And that's 366 feet, I think they said. Oops. So 366, and it's common to use plus slash minus if they say more or less. That. Oops. And actually, this original spot was about 28 feet from, oops, silly. It was about 28 feet from the lake, as I recall, right? Yep, 28.2 feet. So there's another line, one last line, we're almost there. Yes, it is an oddly shaped parcel, but a lot of them are. It's not uncommon. There we are. Hey, it closed and everything. So does that, I find that that's usually more helpful to explain how this process works in concept anyway. The way it works in reality when you're digitizing, there are some additional things that you're going to need to know about. And so just cleaning this up so it can be part of the presentation that I'll post online so you can see it. And so what's the name of the lake here? Indian Lake. So Indian Lake. All right, any questions about this? All right. So, so that's how these measurements, meets and bounds work, and how you translate them into a parcel. What I typically do, and we won't have time to do this tonight, but I'll sort of get you started into the sort of concepts. But what I typically do is for just one, when I have just one parcel, I will look at it and on the deed and draw a drawing like that and then translate it onto the real world. Sometimes, or not the real world, onto a map, right, onto a parcel map. And so that's what we'll work on next week. I got one more thing I want you guys to look at tonight. And that is linked on the page. If you look, we just did the quitclaim deed example. Oh, I guess I had two things. One, let's take a quick look at the example deed involving a curved segment. So I'll open that. You don't even need to open it, but it's near the end under Exhibit A. I just want you to see how these things, where was it? Here it is. So, so this is describing a right-of-way, which is the rights to pass through someone else's property. And so this is how the curve is described. So let me zoom in a little bit so you can see it. So a curve, on a curve to the right, along the easterly right-of-way line of blah, 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 an arc length. So that's the length of the arc, the length of the outside of the circle, the arc length of 104.57 feet to a point. The curve has a delta, meaning the change in angle of that much, and a radius of 1200.78 feet, and a chord of, in that direction of 104 feet. So let me go back here. There it is. So, so there we had the arc length, we had the radius, and a chord is if I recall correctly, is a line from the center of the circle to the circle itself. I think that's right. So anyway, an ArcGIS has little things that, little tools that allow you to actually draw that curve exactly as it's described, which is pretty handy. Okay, now the last thing I want you guys to look at. If you go back to page where it says click here for an example subdivision survey. Let me grab that link. You're going to want to look at this closely. I'll stick it in here. Enter. Okay, so let's take a good close look at this survey. So this is a plan for a subdivision along the Penobscot River. And you can see some familiar features. So notice right here, what is this 204.9 with a little single quote? What does that mean? What is the single quote? It's distance in feet, good. So that's distance in feet. And this is along the Penobscot River, so that's just shore length. And then these meets and bounds, these meets measure the direction. And this is handy because it has arrows. A lot of times you have to just sort of, you have to figure out which quadrant. But this is pointing, right? North 27 west this way, and this one's south 27 east, and so on. Notice that they're opposites, which is one useful thing about using quadrant bearings is that the reverse. So north 27 degrees 44 minutes west is parallel to south 27:44 east. See that? Which is handy. And so it makes it easy to remember. It's easy to draw these out when you go to use it on ArcGIS. Notice too that each one of these has a lot number. It's handy if they calculate the size of the acreage. When you're digitizing, that's really handy because you can calculate the acreage of a parcel that you make and see if it matches. It should be in the ballpark, right? If I were to digitize this lot and then find that it was 1 acre, I know something's wrong. And so that's important as well. Let's see this. So this doesn't have the width of the road here. I don't see it, but that's common to have listed somewhere else. And they may have another map somewhere of that with that information, a closer one. Here's this, we call it crosslink, or somebody had another name for it last week and I've already forgotten it. I don't know if that was you, landhook. So these indicate that that it's the same parcel owned, the parcel is part of the same parcel, but connected across a feature like in this case, a road or some other feature. Other things that you see that are listed or that are shown here. I think, oh, here, right, there's a legend. So one thing too that's handy is showing the locations of utility poles. Now, iron pins are our bread and butter. That's very often if I have to do field work to go find a location, it's those iron pins that are really crucial. These are our soil tests, I think. And maybe utilities were here somewhere as well. And a picture's totally worth 1,000 words, isn't it? I find these much easier to use. And you can georeference these exactly as you would georeference anything else and cut them up, and draw the lines that way as well. All right, so that's where I'm going to leave it for tonight. We'll come back to this stuff next week, and we'll be able to get the get going on digitizing parcels, and you'll get an introduction to it in your labs this week with the editing tutorial. I don't know which camera to look at. I have 2 cameras. Oh, you know, I was supposed to do a code. Thank you. I'm so glad you remembered before I stopped the video. Yes, I have a code, and the code is 5414. 5414 is the code. 5414 is tonight's code. Very good. All right. So that, I got to get ready for my next class, so I better get going. 5414 is the code. And I will see you guys all next week.